The algorithm that builds this search structure that I introduced in the previous video is an incremental algorithm. Later we're going to see that it's actually an incremental randomized, but let's just look at what the algorithm looks like. And if you remember the word incremental algorithm, it's because probably you remember the linear, the LP algorithm, the linear programming lecture. The linear programming algorithm was also an incremental algorithm that you add the constraints one by one. Here we're going to do the same thing. We're going to add the segments one by one and update the search structure at every step. Okay, so first thing we do is create a bounding box and initialize the search structure. At the beginning there is only one region and one node. That is a leaf node representing this this empty region. So in other words, if you give it a query point inside this, I know where it is. I just look at this as a leaf. Okay. Then we create a random permutation of segments. Again, that's going to be surprising. This is not too surprising because the algorithm is going to be randomized incremental. And the main event that we have here is that we're going to maintain a search structure for all the segments that we have seen so far. So we have a for loop, and at the end of the ith iteration, we will have a search structure for all the segments 1 to I. So therefore, if this invariant is true, then by the end of the for loop, we have a search structure for the entire thing, as well as a trapezoid decomposition. So, okay, so let's say we're looking at, again, and obviously at the beginning is true, right? Before at the iteration 0, this is true. Okay, so let's look at the ith iteration. So we have a segment Si that we want to insert into this structure. How do we do this? For clarity, let's assume that the picture looks like this, although we can think of the solution as a general solution as well. The first thing we do is find the trapezoids intersected by the segment Si. Okay. The next step is to cut them into pieces and replace them by the updated segments. And then I'm going to explain the details of how each one is done. But so here we find the green line green trapezoid intersected by the segment Si, cut them into proper pieces and merge potential cells, as you can see here. And then what's happening here is actually very interesting. So we replace the old leaves that were representing the old regions intersected by Si, and we place Si over there. Let me go back just to make sure that you get it. So here the regions C, D, E are intersected by line segment, which means that we're going to replace nodes C, D, E with the segment Si. Okay, and then we create new leaf nodes corresponding to these newly created regions, and we place correct pointers from those new internal nodes S3 to those regions. For example, something like this. And also on top of that, we're going to store this whole thing inside a doubly connected edge list, and we're going to update the doubly connected edge list pointers, which is I'm going to ignore for now because that's long and boring and it's not particularly exciting. Yeah. So that's the overall flow of the algorithm. So it's a very simple algorithm, except that we have some details in it. How I have to show you how we can do steps 4, 5, and 6.